properties of fluids. So there are various properties of fluids like density, specific weight, specific volume, surface tension, capillarity, compressibility. Introduction to fluid properties. So fluid mechanics, which studies the behavior of fluids at rest and in motion. So understanding the fluid properties is very important in the field of engineering. Density. So density is defined as mass per unit volume of the fluid. So the amount of matter occupied in a space, we call it as a mass. So in a volume, if the mass occupied is more, we can say it as of an heavy density. If the mass occupied is less, we can say it as of an less density. So it influences the fluid flow and the buoyancy in various applications. The density of the water is 1000 kg per meter cube. So different fluids have different densities, which affects their behavior in mixed condition. Viscosity. So the viscosity measures the fluid resistance to flow and deformations. So when we take in honey and water, so the water is less viscous compared to honey because the water has a less resistance to flow. But when we take in honey or ketchup, so which is very difficult to flow, it has a good resistance to flow. So the honey is often heavy viscous, so which obviously represent the thickness of a fluid impacting how it moves. So we can categorize the viscosity into dynamic viscosity and kinematic viscosity. So the viscosity of the fluid can change with the temperature and the pressure condition. So the surface tension. So the surface tension is a cohesive force at the surface of a liquid that causes it to behave like an elastic sheet. So it plays a significant role in phenomena such as droplet formation and the capillary actions. So the surface tension is influenced by temperature, impurities, and the nature of a liquid. Compressibility. So the compressibility refers to the change in volume of a fluid in response to the pressure change. So the gases are generally more compressible than a liquids due to the large spaces between the molecules. So understanding the compressibilities is essential for analyzing the behavior of the fluids and under varying pressure conditions. So the compressibility is an inverse of a bulk modulus. Specific weight. So specific weight is the weight of fluid per unit volume, which directly relates to the density. So it's a very important properties in determining the buoyancy. So what is a buoyancy? The buoyancy is an upward force which act on a fluid. So in determining the buoyancy and the stability of a submerged object. The specific weight, which varies with temperature and the salinity in the liquids, so which affect the fluid dynamics in diverse environments. Reynolds number. So Reynolds number is a dimensionless quantity. So when we take off a dimensionless quantity, so it is often Reynolds numbers, Weber's number, Faraday numbers, Mach number. So that predicts the flow patterns in different fluid flow situations. So it helps to determine whether the flow is in laminar or turbulent, which affects the drag and the efficiencies. So the Reynolds number is calculated using a fluid velocity, characteristic length, and the kinematic viscosity. Thermal conductivity. So the thermal conductivity is the ability of the fluid to conduct the heat. So this property is important in energy transfer applications such as heating and the cooling system. So different fluids have a distinct thermal conductivities impacting their effectiveness in heat exchange process. Ideal fluids. So the ideal fluids are the fluids that are compressible and have no viscosity. The real fluids on other hand, which exhibit the viscosity and the compressibility, which affects their flow behavior. So understanding the difference between ideal and the real fluid is fundamental in fluid mechanics analysis. And also there is another properties like specific gravity. So specific gravity is defined as a ratio of a density of the fluid which we want to measure divided by the standard density. So based on the value of specific gravity, we can determine whether the object can sink or float. If the specific gravity value is less than 1, the object will float on. If the specific gravity value is greater than 1, the object will sink. So this specific gravity is one of the important properties in a fluid flow behavior. So the properties of the fluids are essential for understanding various engineering applications. So the knowledge of the fluid properties which aids in designing the system for transportations, energies, and environmental management.